I'm back with another video, and today we're going to learn what is a rational expression. So as you can see here, a rational expression is a fraction where the numerator and denominator are both polynomials. And in simpler terms, it's an expression that can be written as a ratio of two polynomials. Here's an example given. Let's explore what's in the example here. So it's written as like 2x plus 3. The numerator is 2x plus 3. And if you see the denominator, it is x squared minus 4. So let's write it down as well. X squared minus 4. Okay. So is this a polynomial? Well, yes, it is a polynomial. And is this a polynomial? Well, it is also a polynomial. So you just write it in a fraction form, so you'll get a rational expression, which will obviously not be a polynomial. Like this whole thing, this whole expression will be a rational expression, but not a polynomial. Okay, now let's see what is not a what is not a rational expression. Let's see what is not a rational expression. Well, if there is an expression without fractions, now let me give you an example. Like if there is written plain 2x plus 3, what is it? It is a rational, well, it is not a rational expression, but it is a polynomial. But we do not see any fraction in here, so this will not be called, well, will not be called a rational expression. I made a mistake in the slide. Let me correct the mistake. It should be, it should not be polynomial, it should be rational expression. Okay, so expressions with non-polynomial components like square roots of variables, trigonometric functions, exponential or logarithmic functions. Let me give you an example of those things as well. Well, we have seen like square roots of variables in our expressions a lot, but let me just grab an example real quick. I'll be right back. Okay, so I am back with the examples. As you can see, there is this example where we have root x divided by x plus 1. So when we see a square root of variable, that means the expression is not a rational expression. Then we have sine x divided by x squared plus 1. You can see in these points that are written in here that if there's a trigonometric function, sine, cos, tan, and if there's cosec and cot and sec, those won't be like considered in a rational expression. Like you do not want them in a rational expression at all. So this won't be a rational expression. Then we have these two expressions where there is x in here, but the x is in the exponential power. So this is an exponential function. So exponential functions are also not rational expressions, and so are logarithmic functions, as you can see here. Because x is in log, there is a log of x, you will not consider that as a rational expression. Then we have these two expressions here, where there is x raised to the power half plus 3, or 2 raised to the power x plus 1. First problem with this is that we do not have any fractions in here, and other than the power ones, so we do not want things like that. And there is a power which is fractional, and there is a power, which is a variable, which makes it not a rational expression. Then there are complex numbers like iota. Iota is basically the square root of -1. So expressions which have iota, square root of -1, are not rational expressions. Okay, let's check comprehension. Try doing this on your own. Pause the video and do everything on your own, and then we'll see. Okay. Okay, so I hope you have figured something out right now. If you have not figured out, you can just like see what I told you back then. So, what do we see common in these two expressions? Well, if you cannot figure it out yet, I'll tell you what I see common in these. So, in these expressions, let me mark it down for you so it will become easy. So, we have x in the square root, which is what does not make these two expressions rational, which means expression 1 and expression 4 are not rational expressions. So what about the others, 2 and 3? I do think they are like rational expressions because we do not see any like non-polynomials in the numerator or denominator in both of these expressions, so it makes them perfectly rational for me. But if you do think I'm wrong, please tell me in the comments. Okay, so that was it for today's video. I hope you learned something. I hope you liked my video. And if you want any other topics to be made by me, please comment down below and I'll be helping you. Goodbye. Thank you so much.